Hey, hello everyone, Bruno here, and I am going to pick up where I finished last week when we talked about image generation. I figured out the way to do GPU with TransformersSharp in C# with local models, and today we are going to see how that's work, and also we are going to see a comparison between CPU and GPU. So let's go for it, and before going there, remember, subscribe, like, and more. Let's take a look at the code because it's really fun. Okay, now let's take a look at the code. As you can see, it's literally the same that we have in the previous sample, but now we have final. Took me a while, but I figured out how to get the CUDA drivers mostly. It's all about finding the right version of the CUDA drivers, DNNs, and more. A fun story to tell another time, but we have this here, and now we can generate using GPU. What I am going to do right now, I am going to launch the program here. So you are going to see, I'm going to hide myself, and we are going to see that it's going to take some seconds because it's starting the process, but then it's going to use the GPU to generate the image. That the GPU working, we can see the spike there, that's the GPU when it worked there, and we have the image generated here, which by the way, it's super ugly. It's a super ugly squirrel here. If we want to generate another, let's generate another just for fun. Let's do, that's a beaver, let's do a squirrel. Once again, it's done, and hey, there it is. Oh my god, this is super ugly, super bad. I need to improve some parameters here. But as you can see, it literally takes more time to launch and load the pipeline than to generate the image. This is kind of amazing. So now I started to think, how about if I make some comparisons between CPU and GPU? Of course, GPU is going to be faster. But I created the project number 10 here. Take a look at the repo, and the whole idea is that we are going to define literally how many instances we want to create of an image, 20, 25, up to 100, and then the size of the image. They're going to be square, so 128 on 128. And it's going to pick up random prompts. I have a random prompt created here to the image, and it's going to run both. And at the end, it's going to generate a report where we are going to see the comparison. So this is the one running my machine, where we can see here, let me move myself, we can see here that I have a GeForce RTX 4070, and I am going to also take these numbers in mind, that it took 800 seconds to the 20 images or 20 plus images with CPU, 90 seconds for GPU, and it's faster, 88%. So I have this is the prompt, and I have here, the images are going to show, I delete the images. But we can see an example for each one of the prompts. That's the first one, in CPU took 47 seconds, GPU took 6 seconds. And this is all taking in consideration that the pipelines was already loaded, so everything was warm up. This is literally the time to test the images. But what else I did here? This is my local machine, and this is kind of nice. This is what I have here. You already seen this, but I already have access to an amazing NVIDIA T4s. T4s are literally high-level productions GPUs that we can use. So I started to run the same scenarios, going for small images to up to 2 megabyte images. So if I take a look at the first one, when we have here the NVIDIA Tesla T4, we are going to see that it was 86% faster. This is a little less better than in my machine. But when I start to see the images here, and again, the ratio is almost 10%, 9% faster, GPU versus CPU. What I start to see here, if I switch to the 512, I am going to see here that the ratio went up to 90% here, which is kind of nice, and I am going to avoid the middle ones. But here, in the big one, in the 2 megabytes, the improvement rate, it went to 92%, which is kind of nice and kind of amazing. And remember, this is a high-level GPU, so running with GPU, again, no surprises here. It's literally the best experience here. So if you can use this, give it a try. By the way, I need to run this again in a Linux, so you also have the same comparisons in a Linux machine. I already have one Linux machine with a powerful GPU around, so if someone wants, let me know and I can share the Linux also experience there, which is literally no overhead, just the GPU working there. But hey, it's kind of nice. I like it. And again, take a look at the code and everything else, because it's kind of a nice experience to have this here, where you can start to see how you can run everything. And by the way, virtual environments, TransformersSharp is literally amazing for these things. And hey, I hope you like it. It was a really nice experience to, first of all, going back to CUDA drivers, trying to figure out the right drivers, right versions, and more. This is literally hell. If you've never been there, hey, try to avoid that one. Upgrading CUDA drivers is not a nice experience, personally for me, but it was fun. And also, 10 times faster, 9 times, 10 times faster is what I was expecting from GPU versus CPU. And at the same time, I want to see how this works also on Linux, where we don't have any kind of Windows, whatever. On top is literally the GPU working there. I am going to try to figure out the difference there. That's it. Thanks for everything. Take a look at the resources. Probably next week, I'm going to go for agent-to-agents or more. And I don't know, if you want to see something, let me know, and I will try to do a small video or a fast video about this. Goodbye.